Good afternoon, class. College Algebra practice test for Module 5, which covers Chapter 9, Sequences and Series. All right, the first question is asking us to write the first 5 terms of the sequence. All we have to do, replace the k with 1 for the first term, which gives us 1/4 to the power of 0, which means 1 times 9 is 9. We replace it now with number 2, which gives us 2 minus 1 equals 1. 9 times 1/4 is 9/4. And as long as we can show work for 2 of them, we can show work for all of them. And that's good enough. So you want to be able to show work for a couple of steps. Here's the next sequence. We want to find the first term, the second, so on and so forth. So first and foremost, the definition. A difference equation or recursive sequence is an equation of the form a sub n plus 1 equals f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence that has a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. As you can see, the general form is a term a sub n is 2 times the previous one plus the one even prior to that. And 2 terms are given, a sub 1 and a sub 2. So the next one would be a sub 3. Why don't we use this to write a sub 3? So if I replace this n with number 3, this is n minus 1. So I got to replace that with number 2. This is n minus 2. I'm going to replace it with number 1. So take a look. This is the general term. So I have the first one, I have the second one, I need the third one. Here's what happens. And now 2 times a sub 2, I'm going to replace it with number 3, plus a sub 1, I'm going to replace it with number 6. And it results in 6 plus 6 equals 12. Now I have a sub 1, a sub 2, a sub 3. The next one would be a sub 4. So let's replace this n with number 4. When we do that, then this becomes n minus 1, which is 3, n minus 2, which is 2. So 2 times a sub 3. So 2 times what we just found, 12, plus a sub 2. 2 times 12 is 24, plus 3 equals 27. And as long as you can show work for 2, that's good enough. You can come up with the rest of it. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. So what is an arithmetic sequence? What is an geometric sequence? An arithmetic sequence, recursively, a term is equal to the previous one plus d is the distance, which is a fixed number. So you add a number. A sub n plus 1 becomes a sub n plus d. Explicitly, a sub n is a sub 1 plus n minus 1 times d. This is how you come up with arithmetic sequence. For a geometric sequence, a term is equal to the previous one times r, which is a common ratio. A sub n plus 1 is r times a sub n. Explicitly, a sub n is a sub 1, r to the power of n minus 1. So in this case, either you have a common difference or distance, common d, or a common ratio, or none of the above. So you can divide a sub 2 by a sub 1, and then you must divide a sub 3 by a sub 2, so on and so forth, to see if you get a common ratio, or you look at their difference. Notice a sub 2 divided by a sub 1. This is a sub 1, this is a sub 2. Let me write that for you. And so forth. It's negative 2. How about a sub 3 divided by a sub 2? That also gives you the same common ratio of negative 2. It's a good practice to try maybe a couple more to be on the safe side. And if that is the case, this is a geometric sequence with ratio of negative 2. It's geometric with a ratio of negative 2. In this case, we look at their ratio as well as their differences. So if we want to look at the ratio, this is a sub 1. So this is a sub 2. A sub 3, so on and so forth. If we look at the ratio of 8 to 6 and the ratio of 11 to 8, they are not the same. 8 over 6, 11 over 8, 15 over 11, so on and so forth. They are not the same. If we look at their differences, 8 minus 6, 11 minus 8, so on and so forth, they are not the same either. So we don't have a geometric sequence, we don't have an arithmetic sequence. How about this case? Let's divide the second one by the first one. A sub 2, which is 1/2, divided by a sub 1, which is negative 2. That results in negative 1/4. Let's divide the next one, a sub 3 by a sub 2. That results in the same thing. And therefore, it is a geometric sequence with ratio of negative 1/4. Negative 1/4. We want to write the arithmetic sequence for this case in the standard form. In other words, you want to come up with a sub n. We've already discussed the arithmetic sequence in the recursive form, and a sub n is a sub 1 plus n minus 1 times d. Therefore, you need to know what's a sub 1, which is 32. And what is d? 24 minus 32. And you want to check with 16 minus 24, making sure they are identical. So we have a sub 1. We have d. Let's put it into this formula. So replace the a sub 1, replace the d. If we distribute this one, gives us minus 8n. Plus 8. And if we put it in descending order, minus 8n, and then 30 plus 8 gives us 40. In this case, we want to find which term 139 represents if we are dealing with the arithmetic sequence. By the way, even if they don't tell us it's an arithmetic sequence, when we look at this 1, 4, 7, 10, the first term is 1, then 4 minus 1 is 3, 7 minus 4 is 3. So we are adding number 3. So we do have an arithmetic sequence with the first term being 1 and the difference or distance of number 3. Now, let's find the general form a sub n and then set it equal to 139 and find n. So here's the general form. Replace the a sub 1 and d and simplify. This is 3n minus 3. Resulting in 3n minus 2, setting it equal to the number given, which is 139. Add number 2 becomes 141, divide by 3, and we get 47. Find the formula for the general term a sub n of the sequence, assuming the pattern continues. When you look at this, the first term is 0.8, and either we are dealing with a geometric sequence, we look at the ratio to decide, or maybe arithmetic sequence. So we clearly see if we divide 4 by 0.8 or 20 by 4, we get a common ratio. So a sub 1, 0.8, we want to look for d or r in this case. R is a sub 2 divided by a sub 1, which results in 5. And by the way, not only you want to look at a sub 2 over a sub 1, which is 4 over 0.8, you also want to look at 20 over 4. You also want to look at 100 over 20 to be on the safe side. So you make sure you have a geometric sequence with a sub 1 being 0.8, r being 5. Therefore, we use the general term and we replace the a sub 1 and r. Of course, n minus 1 in the case of a part B is 8 minus 1 or 7. And using a calculator results in 62,500. We want to find the 9th term in the case of this geometric sequence. We have a sub 1, we have the ratio, and if we want the 9th term, that means we are looking at a sub n, which is a sub 1, or to the power of n minus 1. A sub 1 is given, r is given, plug in, and what is n? We want the 9th term. So here's the general form. A sub 1 is 4, r is 2, n is 9. All you have to do, plug in. So 4 times 2 to the power of 8 results in 1024. Summation of 3 to 7 k squared minus 1. We want to evaluate this, which means you are going to replace the k with the very first number, 3, plus then the next number is 4, 5, 6, all the way to this last number, this top limit. So the lower limit is number 3, you plug in, you add up all the way to the upper limit, which is 7. So 3 squared minus 1 plus 4 squared minus 1 plus 5 squared minus 1 plus 6 squared minus 1 plus 7 squared minus 1. And you have to evaluate them. Of course, 9 minus 1, 16 minus 1, so on and so forth. And add them up, the result is 130. Now, again, I'm putting the information for arithmetic sequence because we want to write the arithmetic sum using sigma notation. It is important to understand the concept of a sigma notation. That means using a sub n. That's the idea. So before you can write the sigma notation, you have to come up with a sub n. The first term is 9. So we are going down to 4. That means we are adding -5. So we need to find the first term is given. And then the distance, which is 4 minus 9 or minus 9 minus 4. And we can now write the sigma notation. So sigma notation means find a sub n and do the math. You also need to find n. The reason why, because we are writing the sigma notation either to infinity if it says plus dot 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 dot, or in this case up to here. So what term is this? We need to figure it out. All right. So using this formula, a sub n equals a sub 1 plus n minus 1 times d. First, let's figure out what's a sub n in general. Again, this is a sub 1 and 4 minus 9. So this is a sub 1. And the distance is -5. Plug in and simplify this expression by writing this as -5n plus 5. So a sub n is found, so we can put it here. But we are going to go from n equals 1 to what number? We don't know how far we go. We have to figure it out. So this is the last term we are using in this partial sum. Let's set this equal to a sub n to figure out the value of n. So 14, when we subtract from both sides, we get -40 divided by -5 gives us +8. Now we have everything. We have a sub n. We also have the upper limit, which is 8. So a quick recap for this question. For a question like this, we need to figure out what's a sub n using the explicit format. We also need to find the value of the upper limit n by noticing this is the last entry. We use that, we set it equal to a sub n to find n. Now, geometric sequence and arithmetic sequence, again, I have them here. What I'm adding is the summation. S sub n is a sub 1 times 1 minus r to the power of n over 1 minus r in the case minus r in the case of a geometric sequence. In the case of arithmetic sequence is n over 2 times a sub 1 plus a sub n. If we don't have a sub n or we don't want to find it, we can replace this with this formula, which becomes 2a sub 1 plus n minus 1 times d. So in this case, we are dealing with a geometric sequence. We have a choice. We can write this out starting with number 1. That means 3 times 2 to the power of 1 minus 1 plus, we write that, and we don't want to do that, but it can be done as follows. We could say this is 3 times 2 to the power of 1 minus 1 plus 3 times 2 to the power of 2 minus 1 plus all the way to 3 times 2 to the power of 14 minus 1. Can we do that? Yes, but there is an easier way because we notice this is a geometric sequence. All we need to do, use this formula. So what do we need to know? A sub 1, so the first term. If you plug in 1, this becomes 0. 2 to the power of 0 is 1, so the first term becomes 3. So that's a sub 1. Or you may notice this is a sub 1 minus r. So it's being multiplied by the ratio of 2. It's getting multiplied by 2. So you can write this one as 3. The next one is 6, and you continue, and you clearly see r is equal to 2. All right. So we have just about everything. And of course, we have the lower limit 1 all the way to 14, which means n is 14. So in this formula, replace the a sub 1 with 3, replace the r with 6 over 3, which is 2, replace the n with the upper limit 14. We are replacing the n with 14. Let me erase this part so you can see that. This is, of course, -1. Now 1 minus 2 to the power of 14, whatever the answer is, times 3 over -1. That gives us 49,149. Could we have done it term by term, adding them up? Absolutely. This is faster. Now, this is an arithmetic sequence, and we want to find S sub 11. So in this formula, we want S sub 11, which means n is 11, a sub 1 is 9, these 3, just plug in. Everything is given with n being 11. So you replace the n with 11, a sub 1 with 9, and d with 3. So this one is 18, this one is 11 minus 1, 10 times 3 is 30. You do the math, you end up with 264. We want to find the infinite sum, if it exists, for this geometric series. When they ask for an infinite sum in the case of a geometric series, we need to go back to the formula and explore that. Here's the formula, class. When r is between -1 and 1, r to the power of n goes to 0, and the numerator becomes a sub 1. So I want to make sure everybody understands why this is the case. If r is between -1 and 1, pick a number as an example. If you let r be 1/2, okay, and you raise it to the power of 2, it becomes 1/4, which is smaller, okay. And the idea is that if you raise it to the power of 3 is 1/8, which is even smaller. And eventually, as n gets larger and larger, this r to the power of n gets smaller and smaller so that it becomes 0 in the sense of limit, if you will. So with this being the case, let's find r. If r is between the two numbers, then this infinite sum exists and it becomes a number. Otherwise, it diverges as they see, as they mention it, and we don't know the answer. Let's find the ratio. Division of the second by the first, third by the second will give us the ratio. So we know that the first term is -2. We don't know r. And to find r, we just do this division. And because they said geometric series, if you don't check it, it's okay. But just to be on the safe side, divide the third term by the second term, -1/4. This number is between -1 and 1. Therefore, we can use the easy way out and calculate s sub n as n goes to infinity. Replace a sub 1 with the first term, which is -2, and r with -1/4. So the numerator is -2. The denominator is 1 minus -1/4, which means +1/4, which means 5/4. This is a complex fraction. We multiply the top and the bottom by 4, and we get -8/5. Again, we are dealing with a geometric series. A geometric sequence becomes a geometric series when we add them up. And we want to add it all the way to infinity. So whether we ask for infinite sum in this format, or we have it in this format from 1 to infinity, that's the same meaning. And when they ask on a normal basis, you expect R to be between -1 and 1, so you can use that. So it is a geometric sequence. If you plug in 1, by the way, let me just write a few terms for you. 9 1/4 times 1 minus 1, which is 0, plus 9 times 1/4 to the power of 2 minus 1, which is 1, and you move on. The idea is that this thing becomes 9 times 1, which is 9. Therefore, your first term is 9. The second term is 9 times 1/4. You don't even have to write it as 9/4 to see that 1/4 is R. Therefore, we can use this formula. R is 1/4. Using this formula with the first term of 9, we can write S sub n equals 9 over 1 minus 1/4. The denominator is 3/4. And if you divide 9 by 3, you get 3. Multiplied by 4, you get 12 because it's a complex fraction. So again, multiply by 4. 4 times 9 is 36 divided by 3 is 12. Let's look at an application. On each swing, left to right or right to left, a pendulum travels 90% as far as on its previous swing. If the first one is 10 feet, we want to get the total distance traveled by the pendulum before coming to a complete stop. So if you pay attention to this question, this is an interesting application of this concept. We are looking at a geometric sequence with the first one, or A sub 1, being 10 feet. That's what we start with. Okay, 10 feet. And then the next one is 90% of that. In other words, if I were to write the first few, the first one is 10. The second one is 0.9 times 10, or 9. The next one is 0.9 times 9, or 8.1. That's the idea. So we are looking at a geometric sequence with the first term being 10, with R being 0.9. And using the formula will give us the total distance, because now we are looking at a series, because we need to add them up. Therefore, we are dealing with a geometric sequence with R being 0.9 and A sub 1 being 10 feet. S sub n uses the formula, replace the A sub 1 with 10, replace the R with 0.9. The denominator changes to 0.1. 10 divided by 0.1 means 10 times 10. The answer is 100. Because it's an application, we must write units. If units are involved, we must write the units. And the total distance is 100 feet. Here's another interesting application. A ladder consists of 31 rungs. If they taper uniformly from 18 to 28 inches, how much material would be needed for the 20th one and how much material would be needed for all of them. The idea is that it is a arithmetic sequence. So what you need to know, if you look at this one, and of course this doesn't have 31, but the idea is that this is the largest one, this is the smallest one, and uniformly they are getting larger and larger. So whatever this one is, we add a little bit to get to the second one, and we add the same amount to get to the next one, the same amount to get to the next one, so on and so forth. So it is an arithmetic sequence. Therefore, what is given? Well, we have 31 of them. That means n is 31. Okay. The smallest one is 18, a sub 1. If it doesn't matter which one you call a sub 1, which one you call a sub n. The first one, a sub 1, is 18. And the last one, a sub 31, is 28. So this is an arithmetic sequence. A is short for arithmetic sequence. N is 31 according to this. A sub 1 is 18 and a sub 31 is 28. Therefore, we have a lot of information. We can put them all together and figure out the information such that what is the 20th row. So with that being the case, we need to find the d, or distance. So let us use the formula a sub n is equal to a sub 1 plus n minus 1d. And we're going to use it on this one. We know this is equal to 28. We know n, we know a sub 1, and what is missing? D. So in this formula, we have everything except D. Let's find it. So this becomes 30. So we are replacing a sub 31 with 28, a sub 1 with 18, and we are hoping to find D. So we're going to subtract 18, we get 10, we divide by 30, we get 1/3. So the common distance or difference of 1/3, and because the units are given in inches, so the same thing here, 1/3 of an inch. So we are ready to do part A. Part A is asking for a sub 20. How much material would be needed for the 20th one? You want a sub 20. In this formula now, we replace the n with 20. We know a sub 1. We know d. So a sub 1 is replaced with 18. 20 minus 1 is 19. D is 1/3. So 18 plus 19 times 1/3. That gives us 24 and 1/3. Again, applications, write the units. 24 and 1/3 of an inch. How much material do we use for all of it? That means we are here. We want S sub n. We have a choice of using this one or this one. It makes no difference. Because we have the first term, also the last term, it may be easier to use this one. Let's look at that. S sub n is n over 2. So we're going to replace the n with 31 times a sub 1, replace it with 18, plus a sub n, replace it with 28. 713 inches. That is the total amount we need.